Okay, we're back. We're here to do this check-in. Looks like we've got check-in number 1 for mechanics this time around, AP Physics C. So if you haven't tried some of these problems, go ahead and do them and then pause, see, come back, and then check your answers. Horizontal projectile problem for the first one. Object is thrown or shot off a cliff. Velocity in the x direction of 15 meters per second from a height of 2.2 meters. We label it negative because by the time it ends, you'll have a negative displacement. One of the questions is how far does it go? But the first question is if you could graph what the horizontal velocity for part A and the vertical velocity would look like as a function of time. The answer is pretty straightforward. For the horizontal velocity should just be a straight line across because it never changes. There is no acceleration in the x direction, so it should be 0 meters per second squared, so it's a horizontal line. The y component should start at 0. It has no y velocity, but it does have an acceleration of negative 9.8 meters per second squared. So that is going to start at 0 and have a negative, because if you remember from our sign conventions that upward is positive, downward is negative. As it comes down, it'll have a negative velocity. Okay. Part C says how far did it go? So to do that, first you'd have to find the time in the air. So we'd say y. You have to do that in the y direction. Remember, it has no velocity, but it does have an acceleration. So we have the first term 0. If you want to find the time in the air, we would have to double the displacement, divide by the acceleration. In this case, and then we'd have to take the square root, obviously. You have a negative displacement of 2.2, and then divide by a negative acceleration. When you did those problems back in the day, remember those negatives cancel. If you do that, you get a time in the air of 0.6 seconds. The last step would be to find out how far it goes horizontally. So then you just have to know what the x velocity is multiplied by the time. We get 15 meters per second multiplied by 0.67 seconds. And as a result, it ends up going 10.1 meters in the x direction. So that's the answer to the first question. Okay. Let's go ahead and take a look at the next one. There was a last part to that. What is the velocity when it hits the ground later? To find that question, you'd have to say, okay, you need to know the x component of the velocity, square it, plus the y component of the velocity, square it. So use the Pythagorean theorem. I would have to find the y component. I don't know what it is yet. So I just use a v naught y plus at. 0 plus negative 9.8. And then we now know the time in the air is 0.67 seconds. And if you do that, you get that the velocity is like a little over 6, so negative 6.566 meters per second. And then we would go ahead and plug in to find the overall velocity, and it would be 15 meters per second. Quantity squared plus negative 6, which we got 6.566 meters per second. Quantity squared, take the square root, and that gives us 16.4 meters per second. If it asks for the velocity, you might want to find the angle to go with it, and it turns out that if you do the inverse tangent, you get 24 degrees. And that's going to be below the horizontal. It's below. So that would be your velocity vector. So I consider that the answer to problem number 1. Okay. Quickly moving in the next ones. This, I think, on the questions that I sent you, there were some people that had a little bit of difficulty figuring out because I think the question wasn't written carefully enough. I want to know if you do a 200 meter dash, and you know in the first 200 meters, you accelerate from rest and you do it for 5 seconds. A, how fast was the runner moving after 5 seconds, and how long did it take the race? to go. So if you haven't tried that or you had trouble accessing that problem, then go ahead and pause it and try it again. Okay? So if you want to know how fast, I think I would find what the acceleration was. I know that this is a horizontal problem, so I do a v naught x plus 1/2 a t squared. And this isn't a projectile, so ax is not 0. But the first term is 0 because the initial velocity is 0. So if I want to find the acceleration, I'm just going to do twice the distance over t squared. And so in that first part, it goes 25 meters. And you're going to square 5 seconds on the bottom. So 25 over 25 times 2 is 2 meters per second squared. So that's the acceleration. So if you want to find out how fast it's going, if you do v equals v naught plus at, it goes on average 2 meters per second squared for 5 seconds. That's going to be a gain of 10 meters per second. So the answer to part A is at the end of 5 seconds, it'll be traveling 5 or 10 meters per second. Okay, how long did it take to run the whole 200-meter race then? Okay. If it has a constant velocity, then that's just the distance over time. So for the last little bit of the race, or you might say a long part of the race, because it only went 25 meters, so what does that leave? 175 meters to travel in the last part, but you do it at a rate of 10 meters per second. So if you do the math, 17.5 seconds it's going to take to do that last 175 meters. So the total amount of time is going to be 17.5 seconds plus 5. So I got an answer here of 22.5 seconds to be the time for that 200-meter race. Okay. Let's move on to the third question. It's a weather balloon problem. Student is in the weather balloon, and the weather balloon is moving upward with a velocity of 6 meters per second. She will let go of a 2.5 kilogram rock from a height of 12.5 meters off the ground. So she's going to let it go as it's moving upward. With what speed does the rock hit the ground below? First thing is, and I think when I sent you the possible questions, is what would this projectile look like? Well, since the rock is moving with the weather balloon and the weather balloon is initially moving up, I'm going to say that the rock's path is going to look like this. It's going to go up first and then come down. Okay? So that would be the picture of the projectile motion. In this case, if I write down a little bit of what we're given, it's going to have a negative 12.5 meter displacement, an initial velocity of positive 6, and an acceleration of negative 9.8. If that's the case, then you want to know what the speed in the bottom. A lot of these times you might think you might want to use the quadratic to do that, but I think we can just go ahead and use the equation with the squared terms. Vy squared equals v naught y squared plus 2a delta y. Even if you wanted to use to find the time in the air, this might be the easier approach. Depends on how you feel about doing that quadratic. So I'm going to put in 6 meters per second squared plus 2 times negative 9.8 and multiply by a negative displacement. So it's got a positive velocity and negative acceleration and negative displacement. You could do all that in one equation. And when you do that, you get that the velocity is plus or minus when you take the square root, but it ends up being negative because it's on its way down, 16.8 meters per second. So that would be the speed or the velocity that hits the ground if you want to say negative, but if you asked for the speed, you would call it a positive 16.8 meters per second when it hits the ground. Okay. All right. Let's take a look at the next question. soccer goal, it's going to be kicked up in the air at 12 meters per second at a 35-degree angle, and the soccer goal is 8.5 meters away. And you want to know, does the soccer kicker, the player, make it to the goal? Okay. So what you need to do in any projectile motion problem, if you know the angle and the initial velocity, is find the x and y components of the velocity. If you do that, you get 9.83 meters per second for the x, and the y is 6.88 meters per second. Since you know the initial x velocity and the displacement, I'm going to say that if you use delta x equals vt, you could solve for the time in the air. How long does it take for that soccer ball to go that distance? You'd take 8.5 meters and you do it, divide by the 9.83 meters per second, which is the velocity, and then that time in the air is then going to be equal to 0.865 seconds. And the last step would be to find out how high it is, and it's going to end up being v0 yt plus 1/2 at squared. And if you do that, you're going to put in the other velocity and that same time in the air. Don't forget that this term, and maybe I'll just put the numbers, 5.95 meters for the first term, and the other term is negative 3.66 because it's got a negative acceleration. And that ends up being 2.29 meters off the ground. That's the y velocity, or y displacement. Since it's below 2.44 meters, I'm going to say that it makes it in the goal, because it is below the top of the goal. So the goal is scored. Okay? All right. Hopefully that makes sense. The last one. Car moving along a straight road with a positive velocity moves up and down a hill of negligible friction and then proceeds along the level road again. Sketch a v versus t graph for this motion. So I think if you do that, you're probably going to say it's got a constant velocity going along. Then as it goes up, it's going to start to go down in velocity. Then it's got to go up in velocity, and then it achieves that constant velocity when it gets back down the hill because of energy conservation. Okay. Hopefully your graph looks something similar to that. Okay. So those are the 5 questions that we had for AP Physics C Mechanics Check-In number 1. I hope that was useful. We'll talk to you next time. Stay safe.